Hello coders, welcome to my channel. I am Aniket and today we will discuss question 3 of lead code contest, that is maximize sum of device ratings. Let's read the problem. You are given a 2D integer array units of size m cross n where units ij represent the capacity of jth unit in the ith device. So row will store the device and column will store the units, and at any cell, that is device and unit, you have a capacity. I hope you understand this now. Each device contains exactly n units. The rating of a device is the minimum capacity among all its units. It is obvious that every row has n columns. That's why each device has n units, and the rating of a device is minimum capacity of among all its units. So let's say this device is x. So you have to calculate the minimum of this row. This will give you the rating of that device. That is, for device x, the rating is minimum of this row. So I hope you understand this. You may perform the following operation any number of time including 0. Choose a index I that has not been used as a source before. Okay, and remove exactly 1 unit from device I and add it to any different device. Okay, then mark the device I as used so it cannot be chosen again as a source. So you are allowed, we are allowed to do only one, uh, we are allowed to do only one time removal, one time removal from any row. And if we do this same, then we are not allowed to do it again. So the source is only one I, and then again this source is not used. Return the maximum possible sum of the rating of all devices after any number of such moves. Your objective to get the maximum possible sum of the ratings of all devices, not the number of operations like number of minimum operations. Our objective is we want to make our total rating of all devices maximum as possible. So I hope you understand this question. Let's jump to the observation for this problem. Now the question arises that which element we should consider for removal. Let's see the answer for this question with an example. Let's see, there is an array of integers like 3, 4, 5, 7 and 8, and it is in sorted order. So which element you want to remove to get the maximum rating? So if you remove 5, if you remove 5, let's clearly do this. So if you remove 5, if remove 5, then the resulting array will look like this: 3, 4, 7 and 8. After that, the rating of this machine is still 3. Rating is still 3. And if you remove 7, then the rating is still 3, because if you remove 7, the resulting array will look like this, and still the rating is 3, because rating is equal to the minimum of all elements. Here the minimum is still 3. What happen if you remove uh, 3 from this array? Then the array will look like this, and now the rating becomes 4. So here you can find the important observation that if we remove any element other than minimum, then there is no benefit because the rating is still same. But if we remove, but if we remove the minimum element, it is giving us a good rating, a benefit on rating. That's why we should remove, that's why we should remove minimum element, minimum element of all rows. That's why we should remove minimum element of all rows such that our rating will be maximized. And this is a greedy approach. Now the next question arises is where you put that minimum element. This is a very interesting question also because if you remove any element from any row then you have to put this another row. So that's why this is a very interesting question also there, that is where you put that minimum element. The answer to this question is we should put minimum element to that row such that the rating of that row will not decrease. So how can you do this? Let's say the array is 4, 6, 7 and 8 and you put 3 to this array. Then the minimum is rating is 4, but if you put 3 into this the resulting array will be 3, 4, 6, 7 and 8. Now the rating is 3 because the minimum element in this row is 3. So now the rating is decreased, but we don't want that case such that the rating will decrease. So where we should put this 3? So if we put this 3 into this array like 1, 2 and 4 and 5. If we put this 3 into this array, initially the rating is 1, and after if you put this 3 into this array, now the array will become like this. Now the array will look like this, and if you consider rating is nothing but the minimum of all elements of that row, so it is still 1. So if you put 3 to that row which has minimum element lesser than 3, then it will not decrease our rating. But if you put the 3 to that row which has the minimum element greater than 3, then your rating will decrease. So what is the observation from this dry run? So the observation is if we put x to that row where the minimum of that row is greater than x, then rating is decreases. Otherwise rating will not decrease. So that's why we only consider the we only put 3 to that row such that the minimum of that row should be lesser than this 3. So now you will remove every minimum element, and if you remove every minimum element of every row, so you will add units of I comma 1, which is a second minimum element to your answer, because you remove every minimum element from every row. So you will add this quantity units I comma 1 second minimum element to your answer. But there is a row where you can't do this. There is a row where we can't remove minimum element, because all of the removal are put into that. So we can use a principle of inclusion and exclusion principle. We can use a principle of inclusion and exclusion. Let's say you found your answer as answer after all addition of second minimum element, and you have to delete a minimum second element, because there is a row where you will find that you are unable to add minimum second element, and then you have to add minimum first element. In this way you can easily find your correct answer. Now let's discuss the code, but before that please hit the like and subscribe button so that it will motivate me to create such kind of intuitive video for you. I will consistently make such kind of video. Please ensure that you hit the like and subscribe button. Now let's discuss the code. Here is my Java code where the input is a 2D array units, and m is denoting the number of rows and n is denoting the number of columns. If there is only one column, like this is the array, is given, this is a 2D array is given to you. So in that case you will simply add all of the zeroth element to your sum and return this sum. Please ensure that this sum should be of long type, because the return type is long. And but if it is not but if the column size is greater than, if the column size but if the column size is greater than 1, so your 2D array will look like this. Then you have to do this same thing, that first ever you sort your units array, units I, that is the row, sort the row, and in this way you can find the first minimum and the second minimum, and after that you will add some second to your second minimum, and you will minimize your first minimum as math.min of min first comma first, and you will maximize you will minimize your second minimum also, that is math.min of min second comma second minimum, and initially both of them are integer dot max value, and it will minimize whenever possible. And in this case you will simply use principle of inclusion and exclusion to do the problem, where you will some second, and there is a row where you add some second also. So in that row you have to minus min second and plus min first to get the correct answer, because there is a at least a row where you can't find you can't add that element, you can't add the second minimum element to your answer. So that's why we will do this minus min second plus min first. I hope you understand the code now, how the code is implementing the intuition as I discussed before. Please hit the like and subscribe button so that you can't miss any future explanations of any contest. Thank you for watching my video.